Hello! In this video I will show you how DevOps for z/OS works on Azure using the IKAN ALM for z/OS test drive offer. I will share the link to this offer on Azure in the description below. So first, let's go through all the parts that are set up for this test drive offer. We have provided some sample mainframe code which you can customize, the Visual Studio Code IDE, which has Git integration to version your customized files, a local file-based Git repository, an IKAN ALM pre-configured and with a z/OS demo project. IKAN ALM is the actual DevOps software product on this test drive virtual machine that you will be working with. It is pre-configured and set up with a predefined z/OS project so you can start right away. The purpose of this test drive is to provide you the experience of a standard IKAN ALM user. Such a user is able to create packages and launch mainframe compiles and promotes. So here's the scenario. 1. We edit the sample files in VS Code. 2. We commit the changes to Git using VS Code. 3. Create a build in IKAN ALM. 4. Verify this build. 5. Deliver to test and production. And finally 6. We verify the deploy. Let's start with step 1 and step 2. Making changes to the samples and committing to Git. We're using VS Code, but any IDE or editor will suffice. The only requirement for IKAN ALM to work is that your files are versioned. In this case, we chose Git as version control repository. Open VS Code by clicking on the desktop icon. You will notice some files have already been opened and the folder in which these files reside are located in the cloned Git repository. This is your workspace. Now let's edit some sample code. Inside the SRB folder, we will edit the accept1.cbl batch file. We're just going to add some extra characters. That's all. Save the file. We can see that the color of the file in the Explorer has been changed and the letter M has been added to indicate that it has been modified. Next, we go to the source control view. In Git, we need to stage our changes before we can commit. We press the plus sign to stage the changes. We click the check mark to commit the changes. Then we can enter a commit message in the box below before pressing the button. Or we can do this afterwards in a pop-up. Finally, we need to push the changes made in the local repository to the remote repository. So we press Sync Changes button. In step 3, we will create a package and compile the sample code. On our Windows desktop, we will click the IKAN ALM icon and log in with the following credentials: username user and password user. We will then be taken to the IKAN ALM desktop where we can see the project stream of our z/OS demo project. Now, what is a project stream? A project stream is a working entity within IKAN ALM in which the life cycles and their levels, build, test or production, for our demo project are defined. It is automatically created when we create a project in IKAN ALM. Note that for our project the default head project stream is sufficient. For complex projects you can define additional branch project streams. If you need parallel development, for instance. You can read more about this in the IKAN ALM user guide. In the next image you can see the IKAN ALM hierarchy for our demo project. First, let's look at what's inside the package that we are going to compile. In the top menu, click Packages, Overview Packages. On this new screen, we click the View icon in the Packages Overview pane. This will take us to the Package Details screen. As you can see, under the View Contents tab, we currently have 3 files in our package: copy1.copy, accept1.properties, and accept1.cbl batch. When we would have edited other files, we would also need to add them to the package. We can do this by going to Edit Contents and then selecting the files and hitting the Save button. Now, let's get back to the IKAN ALM desktop. In the top menu, we click Desktop. We are ready to build our demo project. In IKAN ALM, initiating a build or deploy process comes down to starting a level request. In this case, we request IKAN ALM to retrieve our package files and perform all the actions that are defined in the build level build ZOS. In IKAN ALM, the build and deploy actions are handled by phases. More on this later. We click the request icon in the build ZOS title of the project stream. Select your package, package 1 first. We provide a meaningful description, but we do not modify the VCR tag entry. This tag is automatically generated and will be created in Git when the build is successful. Optionally, we can have a look at the sources we modified in our package 1 package by clicking the Show Modifications link. Finally, we hit the Create button to start the level request. You will be taken back to the IKAN ALM desktop. There you will notice that the build level title has changed into Running state. It's convenient to turn on the Auto Refresh switch below the menu, so we don't have to refresh the page manually while we're waiting. In step 4, we'll be verifying the results of the compile build level request. When the request has finished, we will see a green icon indicating the request has been successful. The first line indicates the current level request. The second line indicates the latest successful level request. Let's click on the first level request OID link next to this icon. This will take us to the level request details page. If we click on the phase logs tab, we will see an ordered list of all the phases that are used during the build process. When we click on the build number on machine IKAN ALM bar, we can see the phases that ran on the build environment. Take your time to go through all the phases and their logs. Note that when we created the build level and connected the build environment for this test drive, IKAN ALM automatically set up all required general phases. The only thing we had to do was to import the phases that are specifically made to support the ZOS build process. Note that when we created the build level and connected the build environment for this test drive, IKAN ALM automatically set up all required general phases. The only thing we had to do was to import the phases that are specifically made to support the ZOS build process. The IKAN ALM phases architecture is very easy to use and requires no programming skills whatsoever. Under the Results tab, we can see the actual compiled artifacts. We have created a load module, accept1.load, a listing file, accept1.listing, and so on. Because our test drive setup is minimal, other tabs such as approvals, issues, and dependencies are empty. You can read more about these features in the IKAN ALM user guide. Note that every build result is stored in the build archive. On the build environment location, we left the sources and targets from previous build level requests as proof for you to see. Normally, they are deleted automatically. In step 5, we'll deploy the build to the test and production environment. In the previous step, we have built our source code. Now, we want to deploy that build result to our test environment and later on to our production environment. Hence, we need a test level and a production level in our project lifecycle. Let's go to the IKAN ALM desktop. There, we will see a test level test ZOS tile and a production level prod ZOS tile, as we have already set this up for the test drive. Let's click the deliver icon to initiate the test or the deploy level request. On the deliver build page, we select our package 1 first. As you can see, the deliver build screen is almost identical to the request build screen, except that here we can select which build we want to deliver to the test environment. Let's provide a meaningful description. Select the latest build by clicking on the table row and hit the create button. Note that we can only select the build that is available on the build level build ZOS. That's because the test level is the next level after the build level in the project lifecycle. In case we would have selected the deliver to production in the prod ZOS tile instead, only the build that is on the test level would be available. Again, we head back to the IKAN ALM desktop and wait for the level request to finish. In the final step, we will verify the deploy level request or the promote step. Let's click on the first level request OID link in the test ZOS tile. This will take us to the level request details page. If we click on the phase logs tab, we will see an ordered list of all the phases that are used during the build process. Note that when we created the deploy level and environment for this test drive, IKAN ALM automatically set up all required core phases on the level and environment. The only thing we had to do was to import the solution phases that are specifically made to support the ZOS promote process. On the deploy environment location, we left the sources and targets from previous deploy level requests as proof for you to see. Normally, they are deleted automatically. So, this is the end of our very short introduction focused on a typical developer. We only scratched the surface of the possibilities of using DevOps on the mainframe with IKAN ALM. If you need more information, please visit our website. Thank you for watching. Goodbye.